Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. This episode is sponsored by Component One, makers of Wijmo. If you need stunning UI elements or awesome graphs and charts, then go to wijmo.com and check them out. Hey everybody, and welcome to episode 57 of the JavaScript Jabber Show. This week on our panel we have Jamison Dance.
Hello friends.
Merritt Christensen.
Hi.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest. That's Zach Kessin.
Hey everybody.
Did I say your name right, Zach?
Yep, you got it right.
All right. This week we're going to be talking about functional programming in JavaScript. You want to give us a little bit of background on you so that you can kind of explain, I don't know, who you are and your expertise here?
So yeah, I'm Zach Kessin. I'm been a software developer for close to 20 years on the web, since close to 20 years now. Wrote my first web app in in Perl version 4 with MSQL, because MySQL didn't exist yet. That was like 1994. And let's see, I've been doing web applications ever since. Worked in Boston area, in London, and been in Israel for about 10 years now. I'm also the author of Programming HTML5 Applications and Building Web Applications with Erlang, both published by O'Reilly. And my interests include functional programming, code generation, and Erlang, concurrency in Erlang. So that's a different show. So that's sort of my background. And I work at a small Tel Aviv startup called Product Structure that we build drop-in components and workflows that will be self-optimizing on your website. So that's what we're doing. We're launching that soon. So.
Cool. And you just launched your own podcast, didn't you?
Yeah, I just launched my own podcast called Mostly Erlang. It's going to cover Erlang and occasionally other functional languages like Haskell and OCaml. We recorded our first episode last week, and the first episode is called Building Skynet. And the second episode will be on the Web Machine Framework, which is an HTTP framework, backend framework that lets you do some semantically correct web machine. And that it's sort of similar in format to this podcast in Ruby Rogues. So we sort of borrowed your format, Chuck.
That's fine.
We did. I should point that out.
Yeah, you did ask. Well, I actually stole the format from the twit.tv shows. So.
Okay. Huh.
Yeah.
Very cool.
But
yeah.
Zach,
I know a huge portion of our users don't actually know what functional programming is. Could you kind of give a high-level overview of that to start us off?
Okay, so functional programming is a paradigm of programming for which sort of famously done in languages like Haskell and Lisp and Scheme and Erlang, in which basically you use composition of functions as your primary mechanism for building up programs. It works well in JavaScript. When Brendan Eich was designing JavaScript, he stole the function concepts of how functions work basically from Scheme, which is one of the Lisp languages. So you can do a lot of things with functions. It's the thing in the language that Douglas Crockford has said that, and I think he's right, that they got really right, is they got functions right. So basically the way I tend to do functional programming in JavaScript, and I was doing some of it today, is basically I write a lot of little one-line functions. I like one-line functions. They're easy to test, easy to work with. And then you just sort of string them together. I actually tend to use CoffeeScript, not JavaScript directly when I can.
Is there attributes of CoffeeScript that make functional programming simpler, or do you just prefer the taste?
A little bit of both. I prefer the taste. I find the arrow and the fat arrow operators and really nice, as will the destructuring arguments.
Okay.
Really nice, and just the ability to sort of have that sort of more concise syntax. Also use Underscore.js a lot for this to sort of wrap things up and just do that. And you end up with a lot of times using the chain operator in Underscore. You end up with sort of like an algebra of functions. I like to think of it as, where you start with a list, and you just perform a bunch of transformations on it, and you end up with an output list that sort of more or less is what you want. And you sort of just have a bunch of independent steps to get there.
Sure.
Sure.
So So underscore has chain. It seems like it also has things like compose after wrap. Do you recommend all those kinds of things for the functional programming approach, or?
I do. I like the chain approach where you can just, if you have a list of something, either on the front end or the back end, it doesn't matter. You have a list. You might want to filter out some elements. You might want to transform some of the elements. I was doing something yesterday. This is actually on the server, not in JavaScript, but when I was querying some data from a data source, and then needed to drop some records that didn't reach some rules, and then transform it in 6 different ways. So I end up with like 6 or 8 little functions, each does one thing, and then just end up with a chaining operation that just sort of puts them all, they just sort of all run through.
Yeah.
And then build it up one step at a time, and it's really easy to get it right.
Yeah, I particularly like about the chain operator is it usually reads very top-down, whereas one of the things that's harder to grok for functional programming for me is that it's kind of inside-out.
Yeah, that's one thing that drives me nuts. Sometimes drives me nuts too, especially when you start getting into like 6 and 8 levels deep. F of function 1, a function 2, a function 3, a function 4. What you really want to be able to do is decompose that into some sort of, abstract out the flow control in some way. And of course, what you're really getting to there in chain or with like a promise like Q is you're basically working with a monad. I was actually working on a book on monads, but it kind of fell apart.
So monad is always kind of one of those magic words to me. My understanding of monad is it's a function that takes a single argument, but people talk about it like it's a lot more than that.
Yeah, it's a monad. No, that's not a function. So that's not really what a monad is.
Explain
a monad
to me.
is that's guaranteed to break your brain.
I thought monads were just invented so people that wrote Haskell could sound smarter than you. I didn't know they actually did anything. I thought they were just like a thing you could drop in conversation.
Yes, monads are one of the essential aspects of functional programming. They allow us to feel superior to everybody else. And by the way, if you look, there is a running debate online over whether jQuery is a monad, and really only you're talking about the DOM manipulation part of jQuery, not the plugins and the Ajax and all the other stuff. But and I suppose you could do Google queries and say jQuery is a monad and jQuery is not a monad, and see which had more hits. It might be an interesting experiment to try if you want to try that. But basically, a monad, the best way I can think of to describe a monad is it's a programmable control flow. Is really functionally what it comes down to. So the chain value operator in underscore is a monad, as is the Q library forms a monad. Basically, a monad has to have 3 operations. You have to have a thing to wrap a value in the monad, it's going to unwrap it, and then something to sort of process it through. And if that's a lousy explanation, I'm sorry, but it's sort of the best I can do.
So I don't know the theoretical explanation of it, but I've often seen it referred to as a way to wrap I/O or things that need to touch the outside world and do it in a functional way.
In Haskell's case, and I do not know Haskell beyond much beyond the hello world. I mean, I've read a little bit about it, but I cannot claim that I know it. When you're not in a monad, you can only write pure code that can't touch any of the outside world, either reading or writing. So you have to invent all this monadic stuff to be useful. That being said, it's still useful. So one of the most basic monad is the identity monad, which doesn't really do anything useful, or at least not particularly to my. But sort of beyond that, you can go to what's called the maybe monad. I just like having a keyword called maybe. That's kind of cool. And a maybe monad is basically it takes a function that can return. Think of it as an algebraic optional value. So this gets you around the whole null pointer exception. So whenever you have an operation that can return either a value or no value. So like if you want to find out if a certain element is in the list, is in a list of elements, right? It's either there and you return the element, or it's not and you return a null value, which in JavaScript would probably be undefined.
Sure.
So it's sort of like a functional if-else.
Yeah. And the nice thing is you can chain it, so you can have a chain of 10 operations, any one of which can return either null or you can sort of go out to a third level and have an error You have, value, nothing, or error, and it'll just return, basically it'll just sort of iterate down the list until it gets either nothing or an error. In that case, it'll just short circuit the rest of the list so that you end up with this wonderful thing that you don't have to have the whole, all right, if I get the previous stage returns nothing, handle it. If it returns this, you have the sort of
that sounds a lot like promise chains. So I can
it's exactly.
kind of see the connection between them.
And what you can do if you're better at symbolic algebra than I am, you can come up with a general mathematical description of all this stuff, which the Haskell guys do. I mean, if you imagine, JavaScript does not have like a static type system like Haskell does, but you can sort of imagine a type system into it, sort of think about a type. And, you can imagine that basically what a monad does is it sort of modifies the type, where in the maybe monad you either have, a value or nothing, so that you end up with something that looks like that. And then basically you have a control flow that just knows what to do with the right thing, and then you can abstract out your control from your operations. So jQuery has a similar API, whether or not it's actually a monad you can argue about, and I'm not really
sure.
up on
that. Go ahead, Chuck.
I really want to back up here for a minute and just talk about, we hear about these purely functional languages like Lisp and Scheme and Haskell. So what's the difference between these languages and something like JavaScript, which, to my understanding, isn't purely functional?
Right. Well, neither is Lisp, actually. So if you look at Haskell, and if you haven't looked at Haskell, you should. It's got some really cool stuff in it, even if it does break my brain. Haskell has some things that JavaScript doesn't. So first of all, in Haskell, as in Erlang, all variables are single assignment. So values don't change. Second of all, in Haskell, a pure function can have no side effects.
Mm-hmm.
So you have a very strong static guarantee that for any function, if you give it the same input parameters, you'll get the same output.
So you can write purely functional code in JavaScript. It's just not enforced by the language or the environment at all.
The language as you say, does not enforce it. You could probably write some tools that would do that, but the language itself. And in Haskell's case, they can do cool things like, because everything is purely functional, they can evaluate a lot of stuff lazily, where the compiler can say, oh, okay, you've just asked for an infinite list, but I only need the first 3 elements, so I'm just not going to compute those. You can, again, do that in JavaScript. You just have to write some code.
So you say that 2 of the big things are single assignments, which is kind of like immutability, right? Like once it's set, it's set.
Yeah.
And then the other thing is that it's no side effects. And it seems like no side effects occur because of the immutability. Like you couldn't have side effects, right?
Well, no, because Erlang is immutable, but you still have side effects.
Could you explain that?
Okay, so in Erlang, any value once you've assigned it is fixed. You can't say, if you tried to say x equals x plus 1, the compiler would go, no, it doesn't, and, throw its hands at you.
Yeah, but can you do x equals 1 and then later on do x equals 2?
No, not in the same function. But you could have a side effect. You could, print some output or send a message to another process or send output back to the or, interact with other things in the world.
Okay.
So in JavaScript, you don't have the immutability, but you can still have the functional composition where you can use either chain or something or promises to have a very ordered code base. So that's really where it shines in JavaScript, is when you start, especially when you're using backbone and underscore, when you start to just say, okay, I've got a collection of data records here, and I want some result from it, and I'm just going to chain a bunch of processes until I get the information that I want out of it, which could be, filter, then do a couple maps, then another filter, then a couple more maps, then a reduce, and you have the final value.
So I want to ask you about something that's been my experience in trying to do functional programming in JavaScript. And I'm by no means an expert, so I'm sure I was doing a lot of things wrong. But just inside some little system that's pretty self-contained, once I got all the data, and I tried to do everything in a functional style, and I ended up having really complicated data structures because sometimes I needed to return multiple results. So I'd have to like return a big giant array and then pass that into the next thing. And it needed a hash of some stuff from the environment. And I don't know. I just ended up, so since I didn't have objects where I could store state and compute things based on that state, I had to pass everything in and return everything out. So it was like passing the world into my functions and then returning this modified world out of it. And I felt like I was doing it wrong because it seemed pretty complex. I mean, I could see the benefits for testability where you have everything you need in the arguments and stuff, but it didn't seem to make the code any better.
Yeah, I've had that too, and there's sort of a couple ways you can sort of deal with that. First of all, you can sort of just capture intermediate results and branch them out and remerge them later. That's one approach.
You just warped my brain. Could you explain that? What you just said?
Oh, sure. So, say, for example, in jQuery, you could capture some DOM elements, do a couple operations on them, assign that result to a variable, do something else, and then do a couple more operations.
Okay.
Or
like a variable outside the scope, you mean?
Yeah.
But then don't you throw away the testability at that point?
It's
not if you test function. Like it seems like you kind of encapsulate anything that is purely functional can do whatever it wants in the middle as long as it's deterministic with its inputs and outputs, right?
But if your function is talking to some variable that it depends on some scope existing.
Oh no, I mean I'm not so much test depending on some variable so much as just your chain simply returns a value at the end. And then you use that value to simply restart another chain later.
So kind of split, instead of chaining everything together in a giant list of 10 functions, and maybe to do that you need to have a more complicated data structure. You might split out the things that make the data structure complex into 2 chains and then like combine them at the end or something like that.
Yeah, you can do that with Q. There's some nice things. If you have like 3 or 4 promise chains going, there's an operation in the Q library, and I forget what it is, that lets you say, okay, when all of these complete, go on. So if you have, you're waiting for 4 things to happen, you can just sort of say, okay, when all of, promise 1, promise 2, promise 3, and promise 4 are done, create a joint promise, basically. And you can do that in Q. I forgot the exact syntax, but you can do it. Honestly, I've been staying out of JavaScript the last few weeks as much as I could. The front end of our company is being done by a different developer, and I'm mostly handling the API side.
Sure. So we kind of have touched on them a little bit, but I don't know if we've actually enumerated the reasons why you would want to do functional programming, especially in a language where you can do object-oriented or procedural, whatever kind of programming you want, like JavaScript. So do you want to just enumerate some of the benefits, like make the case for doing it?
Okay, so first of all, you end up doing a fair bit of it anyway, because in JavaScript you end up throwing around functions for callbacks and stuff. So, especially using something like the Q library, the promise library that you guys talked about some episodes back, by the way. Find a link to it in a minute. You can end up avoiding the sort of callback ladder of doom, where you end up with 6 callback levels deep, which I know I've got. I assume everybody else here has done. You kind of want to avoid that. And then also, in say when you're trying to process, using a list, process a list, you also can get that. The other thing is, it's just a very powerful metaphor, a powerful mechanism, especially when you start going into, we haven't talked about higher order functions, where you have things like map, or you can construct your own, where you can sort of abstract out some detail, where you just say, okay, we haven't touched on this more, where you can create a function where the part of the operation of the function is another function, where you can pass in sort of abstractions. So map and reduce and those functions are sort of good examples, where you say, okay, I want to do something to every element of this list, or I want to do something to every record in this data set, where you just say, okay, I know how to handle one element, so now I just need to scale that up to handling n elements. It's kind of cool when you can sort of spend a whole day writing code and never use either an if or a loop in any way. I've done that a couple times, sometimes without intending to, but it's sort of I haven't used a loop in 3 days. So, but the ability to use higher order functions is something that's very convenient. And even in non-functional JavaScript, for example, I've been playing with Ext JS a little bit recently. And, in the Ext JS store, the filter, there's a filter bar. You pass it a function and you say, apply this to every element in every record in the store and filter out all those for which it returns false, which is again very convenient when you're trying to just say, okay, I want to show a subset of my data. You don't have to just come up with a general rule for filtering. You just say, I'm just going to pass you a function and it's going to figure out what to show and what to hide. And that function can change as you post things in your interface or things like that. So that's and of course, you don't have to, in JavaScript, probably shouldn't do functional programming exclusively. I mean, you can if you want to, I guess. But it's nice about languages like JavaScript is, since it is a multi-paradigm language, you can use functional programming where it makes sense and then go use object-oriented programming in many of the same places.
Right. Even chain, like the underscore chain example we've been using, that's not purely functional, right? Because you're kind of creating this object that stores the state internally and calling methods on it.
Right. I mean, you're creating, it's, the thing is, every iteration through the chain, you're actually returning a new object. You're returning a new wrapped object. So
you're not modifying the original values that were put into it.
The initial values. You're simply creating a new version of it with jQuery.
Interesting. Okay, so these aren't all methods on chain that eventually return chain. It actually is passing down this underscore wrapped. Oh, that's kind of cool. Okay,
yeah, kind of like the map reduce example again. I mean, you map, but you have the original values off in some variable somewhere else, and it's returning a new set of values every time you call map. And then at the same time, and then when you call reduce or filter or anything like that, again, you're getting a different set of values. And it may be a reduced set of values. It may be a specific subset of the values you had before, or it may be some view on the values that you had in the original set, but it's not changing the initial values, so you still have those off somewhere else that that you can always call back to.
Right.
Sure.
jQuery is the same, where when you first launch, when you capture something with the $ operator in jQuery, and then you do dollar selector dot show dot something else, dot fade out, whatever. Each of those times it's returning, you're actually getting a new jQuery object that's from a transmutation of the prior one. So you can actually capture that in a useful way. So basically, in the chain, you are actually transmuting you're actually not changing the initial values. You're simply creating a new set.
So essentially, So when you're doing underscore.chain, it's kind of the same thing as just wrapping something in the underscore object and then going from there, right?
Exactly. Yeah.
Interesting. So chain is just kind of longhand for that sort of wrapping approach.
Yeah, I mean, the great advantage of it is if you're going to do seven operations or 5 operations or whatever, you could do value 1 equals map underscore map function initial value, and then sort of just assign it to a new intermediate value every time. But this just means it just sort of saves you notation.
Got it.
So one thing I noticed in my experiment with doing stuff in a purely functional style is I was doing a lot of copying. Is that something that languages that are more designed for functional programming will take care of for you? Where maybe they'll yeah, I was copying a ton of data around so that I wasn't modifying stuff and then not returning anything, but just modifying the thing that gets passed in. Is that something that compilers in Or languages themselves will take care of for you to do that in a more
usually,
efficient way?
I mean, usually. And you also just only learn to pass in less stuff.
Yeah.
Get the habit. And the other thing that JavaScript doesn't have, unfortunately, that would be really nice for functional programming style is any sort of tail call optimization, which...
Can you explain what that is?
Okay, so if you have a function that ends by calling another function, but the last thing is just a call to a second function, what a lot of languages like Lisp or Haskell or Erlang will do is instead of adding a new stack frame, they simply replace the prior stack frame with a new function. So in Erlang, for example, in Haskell, it's the same. There's no loop up. There's no for loop because you can't mutate variables. So you loop by doing recursion. Now you can, by using a tail call optimization, you can recurse effectively
without blowing up your stack,
and the stack doesn't grow.
Sure.
And so I'm just trying to wrap my head around this. So when you recurse, okay. So let me back up. So the way I understand Lisp and some of these other languages work, you have the cutter and the car.
Yeah, Lisp is famous for giving things functional names.
So it's the first element and then everything else.
Right. So if you have a Lisp list, you have two operations. Car, which is the first element of the list, and cutter, CDR, which is basically the tail of the list, everything but the first element. And those names relate to the architecture of an IBM computer that was current in 1958.
Yeah, the names are all pretty funny.
But so anyway, so when you're talking about recursion, what you're saying is you have an operation that operates on the car and then calls itself on the cutter because the car of the cutter is the next element.
Exactly. And of course you could do this in JavaScript quite nicely. I mean, it doesn't have to be. I mean, you could also use recursion to do a binary searching through a binary tree or lots of other things. One place I've ended up using this sort of operation, although it's not strictly speaking recursive in terms of the code, it is logically in JavaScript, is if you have a list of things you need to send to the server, if you have 20 elements you need to send to the server, and for some reason you don't want to put them all into one AJAX call, because, I don't know, it would blow up your server or something, basically you can use that type of operation where basically you send the first, you treat it as an array, you send the first element to the server when the AJAX call returns. You then just take the list, the remaining list, which is, all of the list minus the first element, and apply it again, and just keep repeating until you run out of elements. I've done that in JavaScript once or twice for reasons that I don't remember. Normally, obviously, you'd just rather send the whole thing in one go, if you could.
Right.
But it doesn't have to be that. I mean, you can do recursion for sort of any number of things. If you want to compute the Mandelbrot set, you can. The algorithm is nicely recursive. In Haskell or Erlang, you can do a quicksort in one line of code through recursion. It's not necessarily the most efficient implementation of quicksort, mind you, but it's one line of code. It's like 2 lines of code. It's really impressive.
Mm-hmm. So can you explain now in terms of the the first element and everything else how the tail call optimization works?
So normally when you're in a function, you call another function, you add a frame onto your stack. Mm-hmm. So, and since your computer is finite, your memory is finite, at some point you run out of space on your stack. In JavaScript, if you recurse infinitely, at some point your stack explodes and your code crashes.
Right.
Now, in languages that use recursion very heavily, of which Lisp, most functional languages that don't run on the JVM fall into this category. What they do is basically, in cases where they can, in some cases you can't, basically when you make that call to that next function in line, instead of pushing another frame onto your stack, you simply pop the current frame off and put the new frame in as a replacement. So you can recurse infinitely and never the stack with a constant stack.
That makes sense.
Now this doesn't work if you need to operate on the return value of the call function. So if you say, so if you're this would be a stupid implementation, but if you're using recursion to add a list of numbers, you said, okay, the sum will be 1 plus the sum of the rest of the list, then you can't do that because you got to return the rest of the list, then add 1 to it. So you still need that stack frame. That's probably not the best way to add a list of numbers, but it was just sort of a simple example. So that's how you sort of do that. I think I read that they're talking about adding tail call optimization into whatever the next version of JavaScript will be, but I have no idea when they're going to do that, or if they're going to do that, or what the timetable is.
We had the opportunity to talk to Dave Herman about this exact thing a few episodes ago, and he mentioned they absolutely are, and he explained it as well. So if anyone didn't grok your explanation, we also have David Herman's explanation.
Which episode? I hope I caught that one. I'll just go check.
I have to say that this is one of those things too that you have to kind of hit your head against a couple of times before you really get it. So I highly recommend, if you're trying to understand, the approach and tail call and all this stuff, that you listen to both episodes, listen to both explanations, because they explain it a little bit differently, and hopefully then you can get your head around the concept that we're addressing here.
It might also be useful if you really want to get your head around the concept to step away from JavaScript a little bit and go play with Haskell or Lisp or Erlang or one of the languages that really emphasizes this stuff, probably Haskell or Lisp, and play with it for a while and really get your head around it in a different language where you can sort of, you don't have to try to, where you sort of have a blank slate. Because the thing is, if you can figure out how to do something cool in Lisp or in Scheme, you probably can take that solution back to JavaScript with you in a way that, if you just stay in JavaScript, you might not. So it's one of those reasons why learning a new programming language every so often is just a useful skill. It's a useful thing because, if you learn a new language, you'll discover it does something really awesome. If you haven't read the book 7 Languages in 7 Weeks from the Pragmatic Programmers, you should do. If one of those languages one of the 7 doesn't make you sit up and go, oh my god, that's the coolest thing I've ever seen, you're in the wrong line of work. Because I don't know which of the 7 it'll be. For me, it was Prolog, which I've never actually used. They present a Sudoku puzzle solver, and it's like 20 lines of code. And it's like, you're looking at it going, where's the program? That can't
That's awesome.
I mean, it's like, oh my god, this is the cool. And, maybe for somebody else it'll be, Scala or Erlang or whatever. But I fundamentally feel that learning 7 programming languages, one of them doesn't make you sit up and go, oh, that's just cool. You shouldn't be a programmer, Yeah. I don't care which of the 7 it is. It just better be one of them, at least.
Yeah.
Are there any? I know there's some heavy functional programming libraries, libraries that focus explicitly on this kind of stuff. There's Valentine. Jamison, what was the name of that library that JavaScript Elongay is working on? That book. Do you remember?
Oh no, but I have Google.
Well, I'm wondering if you know of any functional libraries in specific that, aside from Underscore, that you recommend for learning this kind of stuff. Stuff that maybe has things like Maybe.
I actually have an implementation of the Maybe monad somewhere. I think it's in a gist. Let me see if I can find it. So here's an implementation of the Maybe monad in CoffeeScript. Not
very
hugely
cool.
tested.
We'll post that to the show notes.
Yep.
The Q Promise library is one I like a lot because it solves a problem that if you're doing any sort of JavaScript development, front end or back end, you have, which is the callback hell.
It's so interesting that you reference Q because I've been using Q for a long time and I've loved it, but I never considered it a functional programming approach. Yeah,
well, the truth is, I found out about it through you guys. I found out about it. I was like, hold on. Started reading about it. I started reading it. It's like, hold on. I think that's a monad. And I sat down and worked out the math. And I'm like, yep, it is.
So Q seems cool because it seems like a way that you can make things that aren't functional into functional, a functional style. Because you take things that have callbacks and asynchronicity, and you can turn them into things that just take an input and return an output.
Absolutely. Yeah. Q is just wonderful.
It's the idea that you can take the sequencing aspect and separate it out from the functional aspect, small f functional, or just sort of the, take the sequencing and separate it from this is the problem I am trying to solve aspect. Okay, this is going to happen, and then this has to happen when it's done. Okay, I don't need to know the mechanics of how that works. I just want it to work. And I'm a big fan of the whole higher abstraction. I spend a lot of time in Erlang where error handling is inherently handled somewhere else. The motto of the Erlang work community is don't write defensive code ever. Well, almost ever. So
I have one more question, and then we're going to get into the picks, and that is, what do you find that you miss the most when you're working in something like JavaScript where it's not totally functional? And what do you find that you miss when you're working somewhere where it is totally functional?
So the thing that I miss the most when I'm in JavaScript versus Erlang isn't necessarily a purely functional, it's a syntax thing, but it's pattern matching. In Erlang, you can say, okay, I have 4 clauses in a function, and depending on what the input is, it'll run the right one, and it's just very concise. And then also the concurrency model in Erlang is just really nice. In terms of the other way around, what I really like about JavaScript is, and CoffeeScript for that matter, is it just has wonderful syntactic sugar. You can make the language do almost anything. I mean, it may come around and bite you later, but it's a wonderful syntactic sugar where you can say, oh yeah, I can just make it do that. We've taken this language, which is in some ways syntactically not so wonderful, and then we've just added things like Q and underscore and jQuery, and we've taken, if you actually tried to do raw JavaScript interfacing with just the DOM, if you told me I had to do that, I think I'd, go shoot myself or something, because, really, I don't want to do that. I've done that. It's not fun. It's really not. But you start adding Q and jQuery and underscore and all these other things, and suddenly it's like, oh, okay, yeah, this is actually really nice. So that level of syntactic sugar, where you can just say, oh yeah, I'm going to take a couple functions from over here and stick them over there. Yeah. That's really awesome.
All right, cool. Well, we're right about at our time limit, so I hate to cut you off, but I'm going to.
Always do a part 2 some other day if we want.
Yeah, that's true. All right, well, let's go ahead and do the picks. Jamison, why don't you start us off with the picks?
All right, I'm going to go with 2. One of them is this video by someone called Hart. I've never heard of her before, but Isaac's posted this on Twitter a couple weeks ago, and she's talking about the normalcy of pi. And she has a bunch of videos like this where they're about deep mathematical things, but they're explained in a really clever and easy to follow way. It's one of those YouTube things where she makes like a bunch of drawings and records herself talking over the drawing that kind of explains what she's talking about. So it's really well done. And then my next one is continuing my series of goofy Tumblrs. It's sports balls replaced with cats.tumblr.com. And it's what it sounds like. They take pictures of athletes like slam dunking a ball, and then they Photoshop a cat in place of the ball. So it looks like they're slam dunking a cat. It's pretty great. Very mentally stimulating. Those are my picks.
Awesome. Merrick, what are your picks?
So my picks, since we're talking about functional programming with JavaScript, I'm going to pick this book, JavaScript Allonge. I think it's Allonge. It might be Allonge. I don't know. But it's a book on functional programming, and it also has kind of a library. It talks a lot about the things we discussed today. And then secondly, I've been using this library called Bonsai.js, and it is awesome. It's kind of like the good abstractions of Flash in the browser. Oh, it's awesome for really rich animation kind of projects.
Awesome.
Check that out.
Cool.
Sweet.
Thanks.
All right, my picks this week. My first pick is there's a video from the International Space Station of an astronaut wringing out a soaking wet rag of water.
Oh, I thought that was awesome.
It was really, really cool. So I'll put a link to that in the show notes. It was awesome. So anyway, I really, really liked that. And the other pick I have is something that we've talked about. We actually had an episode on it, but I picked up a contract that wasn't Ruby. It's JavaScript, and we've been using Recursion JS and AMD as part of the project, and I have to say that there's some pretty awesome stuff in there. So it's one thing to talk about it, but it's another thing to actually use it. And so
it's wonderful. Yeah, it's awesome.
Yeah. I'm still getting used to some of the patterns for use that it has, but it's in some of the areas it just makes things a whole lot simpler. So anyway, Zach, what are your picks?
So I've got a couple. Tech pick. First of all, I'm going to pick my own podcast, mostly Erlang. We mentioned it earlier, but people would go and subscribe. I'd be very much appreciative. It's just getting off the ground. We've got one episode recorded so far, and hopefully a second by the time this comes out. As I may have mentioned earlier, I live in Israel, but I'm originally from Boston. So I just want to pick, as sort of an honor, all the first responders in the greater Boston area from the last couple of weeks' work. It was kind of a frightening time for all of us Bostonians, even those of us who are far away. So it's nice to know that we got good people. And the third thing is a piece of Israeli tech that I'm really impressed by. It's called the Iron Dome. So it's an anti-missile system that basically is designed to take out short-range rockets. And it can basically spot a rocket launch, and within about the 15 seconds of flight that the rocket would have before it hits, determine whether or not it would hit populated civilian areas, and if so, fire an interceptor and take it out with about 90% reliability. So it's during our last round of conflict, it reduced casualties all around.
I don't care which side of the conflict you're on. That is cool technology.
It really awesome. is. I'll send you a video. This is from here. Let me just send you a link. It's purely defensive tech. All it can shoot down is incoming rockets. I sent a video. It's from a wedding that was in Beersheba, which is in the south of Israel. And they're at this wedding, and the air raid sirens are going off. Everybody runs for cover because when the air raid sirens are going off, you run for cover because you have about, depending on where you are, between 15 and 90 seconds to run for cover. And you just see these rockets come out and there, and then the all clear sounds. It was, truly astounding. Thankfully, where I live is far enough out into the boonies outside Tel Aviv that I didn't actually hear. The only air raid siren I heard was a drill from the school around next to my house. But it was a fairly scary time, I tell you. But yeah, it's truly amazing technology. They did a huge job of it, and I just have to thank all the people involved in both Israel and the United States, because the U.S. government paid for a large chunk of it. So, yeah, better living through technology.
Cool.
Sweet.
All right. Well, that's the show. Thanks for coming, Zach. It was a really interesting conversation.
Yeah, thank you.
Yeah, thank you. Thank you so much. Like I said, I've been a fan of the show for a while. So.
All right.
Yeah, thank you, man.